Hello everyone, Simon here from the Changer project. I wanted to give you an update about the work I've been doing the last month in the project. So it's still a work in progress, but it's taking shape now, finally, after some few years of hard work. So yeah, basically on the software side, the macros are implemented to control the printer. So let me show you that. So basically you can control over the macros lighting, for example. So as you can see, I can control the light, of course. But I can control the implemented air pump as well. So let me show you that. So now you can hear the air pump working, so I can basically use the air pump for vacuum, so to have some pick and place application, but I can use it for cooling purposes as well. So I can use the stream, the air stream, to cool down some parts in a printing application. Let me deactivate the air pump. So the radiator for the fume extraction you see in the back. So basically, let me open the door quickly. So open this one as well. Sorry. So basically here in the back side of the printer, you see here there is a HEPA filter system with some exhaust fans to clean the air inside of the printer from printing fumes and small particles in the air. So that's what my radiator, what my exhaust fans mean. So now you can hear the fans working. So basically you can start this manually, but of course you can start this while printing with via the G code as well. So as soon as you start printing and you have some fumes to be expected, like ABS or stuff like that, so then you can of course start the air pump via G code. So let me stop that. Here it was exhaust fan. Then I have a radiator as well. This is for the water cooling, but I won't do that because I do not have some water inside of the loop, but here is the radiator for cooling the water cycle as well. Next up we have the door system. So I worked the last few weeks on a hinge system to comfortably open and close the door, and I didn't want to use just a normal hinge style with just a rotating axle to open and close the door. So I wanted to have something more sophisticated, like something like that. So basically this opens up in a more mechanically fashion and has the benefit to fold completely down onto the top of the printer. So this would mean that you do not have to hold the door in the locked position, and you can easily work inside of the printer, and if you're done you can close it up again. So I will show you a simulation or a quick demonstration of the actual mechanics. See you in a bit. I've designed this more mechanical, sophisticated hinge, which has the benefit to being able to fold the front door completely to the top of the printer, which I try to showing you here. So as you can see, the door is now completely open up and laying on top of the printer. So let me close it back again so you can see the mechanics working. So it folds easily down, and at the end position you can push it upwards to lock it in place. As you can see here, I didn't manage to bend the front panel according to the actual door opening, so now it's just a sheet acrylic cut with a laser to the shape, but now I have to come up with some sort of bending machine or bending tool to help me heat up the front panel and then bend it into place, so the front door is sitting perfectly inside the frame. Now let's continue to the first compartment of the printer. So some of the electronics are hidden underneath this protection plate here, so let me remove that, put it away. So as you can see, in here we have the main power supply of the printer, powering 12 volts. I guess it's one from Meanwhile. And here you can see a switching relay, a solid state relay for the bed, for the heating bed. Because I'm using mains voltages, I have to switch the heat bed differently, and I have to note here you have to be quite careful, and the whole printer is bound down to earth, so that it's safe working on the printer. But of course, if you work on the printer, you have to take care you plug or deplug your printer from the mains, of course. Maybe you already heard before in the video, because I switched on the air pump. Let me do it again. So as you can see, I can go into the macro, turn on the air pump. So basically this is the air pump, somewhat damped from the main system, because it's placed on elastomeric dampers to reduce the noise of the pump. So let me just deactivate the pump again. Underneath you can see in here in the background, or you can't see it clearly, but here in the back side of the printer there is a Raspberry Pi waiting to be programmed to work as a server to keep track of all the different tools. So talking about tools, the drag knife is already done. So that's the second tool after the printing tool we see here on the left. This is a direct drive printing tool waiting to be tested again. But second tool, it will be a drag knife, which you can see here is basically a simple drag knife holder, which is pressed down by a spring. So let me quickly zoom in to give you a better view. So here you can see the drag knife. So this is just a simple sliding holder for a state-of-the-art drag knife. So you can buy this directly from Amazon, AliExpress, Banggood and stuff, and shops like that. So basically what I did, or basically what I've done actually, I've created this holder to have it spring-loaded. So basically it slides upside down, but it should be constrained pretty good. So in the X and Y direction it should be stable, and only if you have some different or variance in thickness you should be able to apply some pre-pressure to the drag knife. And of course you have your standard carbide blades for the drag knife for different materials, and of course with different offsets of the drag knife. And these tools, I didn't have the chance to test it because I'm still waiting on some magnetic sheets to put on my cutting, let's say my cutting plate, to not damage my actual printing plate. But this is work in progress as well. Maybe you've already wondered why there are some openings in the top part of the printer and as well in the plate which we removed recently. The main idea was to use a heating system to heat up the build chamber. So this unit looks like this. So basically you can place it in there and you have a dedicated 230 volt main heating unit which has a power, I guess, of roughly 400 watts, so it should be able to heat up the room quite quickly, but I still hadn't figured out how I can switch it on and off sufficiently, so that's why I still have just a mains cable here. I'm using a control circuit to switch on 330 AC, but I guess because of the internal resistance or the way this heating unit is built, you can't use an AC switching supply, so I have to come up with something different, or maybe just use it more statically, so just put it on and off. But I wanted to have some kind of regulation inside of the printing, so I can regulate to a preset room or chamber temperature, to be more precise, but this doesn't work yet. I'm still working on a different solution, or maybe even consider a 12 or 24 volt system and not a 230 volt system, because I do not need high printing temperatures, and I didn't want to insulate the printer too well to accommodate the design I had in mind. So because I went for the acrylic panels, and my top, or let's say my top cover here, it's for printing high temp materials. It's not the best insulated design, I know, but I didn't care for that reason, because I like the design even more, and if I have to print high temp materials, I will just use a different style of printer. So that's why I didn't work on this heating problem with full force, but I still have in mind some other options. So that's why the grids are placed already there, because I didn't want, or I wanted to have some kind of heating system which can be used to heat up the chamber. So this is it for the first update. So like I said, I want to get the bend done so it closes up completely, and then I can actually design the locking mechanism on the bottom. Then I will continue on the drag knife, try to get it working with software, and of course create some new tools. So as you can see in the background, I already started to print out the direct spindle tool from E3D. I did some small changes to that. I still waiting on some parts, and then I will continue on the laser module. I ordered a 40 watt laser from NEJE, is it called, I guess, and for that I have to design a tool head as well. I try to keep the updates coming, so thank you for your time, and yeah, create a comment if you have questions. I love to answer your questions, and see you in a bit. Bye.